Welcome to today's video, Aristotle Part 2. We're going to be continuing last week's video on what Aristotle's science was and why he was the most influential scientist of all time. Today's videos are going to be broken down like this. First, we're going to talk about Aristotle's cosmology, then we're going to talk about his beliefs with motion, and finally we're going to discuss just a little bit about why he was the most influential scientist of all time. Today's video is adapted from information in David Lindbergh's book, The Beginnings of Western Science. If you want to read more about what I'm talking about today, please check it out. I'll link that down in the description. Section 1, Cosmology, and a little bit of motion, because it is relevant. But also I want to have a section just for motion. As much as I hate simplifying history, one really good way to remember what Aristotle's universe looked like is the 3 F's: fixed, full, and finite. So what do these mean? Fixed meant that Aristotle's universe had a center, and that center didn't move. Today, that center has shifted to me, where I'm at all times, coincidentally. Earth was at the center of the universe, but not just because everything revolved around the Earth. Except, confusingly, everything did revolve around the Earth. What I mean is the elements and other celestial bodies rotated around the center of the universe. And because of this center of the universe property and other properties the elements had, the Earth just happened to form right in the very center. That brings us nicely to our next F. Full. Full just means that Aristotle's universe is like your overly nostalgic Aunt Regina. She swears she doesn't have a hoarder's house, but when you get in there, it's absolutely filled to the brim with stuff, and there's no empty space. Same thing with Aristotle's universe. There was no empty space. Aristotle believed in the elements Avatar style. No, not like that. Not overly sexed blue people, but rather awesome airbender style elements. From Empedocles and passed down through Plato, Aristotle believed that the most basic building blocks of everything were the 4 elements: earth, water, fire, and air. Technically, the elements were further reducible into wet, dry, hot, or cold, but that's unimportant for this video. The elements were drawn to their natural place in the universe. Earth, being the heaviest element followed by water, were naturally drawn to the center of the universe to form the globe of the Earth. The next heaviest, air, forms a sphere around the Earth, followed by the lightest element, fire, to form a sphere around the air. This leaves us with a set of concentric spheres, composed of Earth, the elemental kind, followed by water, air, and then fire. However, Aristotle stressed that this would be an ideal form, and instead the elements formed mixed bodies, giving us the planet Earth and the surrounding atmosphere as we know it. So why was everything full and in a state that would give Marie Kondo a stroke? Aristotle believed that every nook and cranny was filled with one or some combination of the elements. For example, a piece of bread. When you cut it open, there's little air pockets inside. For Aristotle, it made sense for smaller and smaller spaces, even those that couldn't be seen, to be filled with tiny amounts of elements. Now Townsend, you say, what about planets? What about space? What were they filled with? Elements? Nothing? Silly string? That weird residue that's left when you peel gum off of something? And to that I say no. See, before I lied, you idiot. You fell victim to one of the classic blunders. Aristotle actually believed in 5 elements, and not 4. He called the 5th element quintessence, or literally, the 5th element. And for right now, it's enough to know that Aristotle believed that everything in space was filled with quintessence. As a side note, Aristotle didn't think or use the term space as we know it, but I'll explain more on that in a little bit. The part about elements coming to form spheres is important, and it brings us to our last F: finite. Aristotle believed that the universe was made up of a set of interlocking concentric spheres. Some for stars as we know them, calling them fixed stars, as they appeared fixed on a single sphere, like colors on a beach ball. If you imagine a giant colorful beach ball, when the ball rotates, the colors rotate. In this case, the colors would be the stars, all rotating on one large sphere. The planets, which Aristotle confusingly called stars, also had their own concentric sphere. But the important distinction, and what we'll be talking about later, are the areas above and below the moon, known as the superlunary and sublunary spheres respectively. All the spheres moved, and they are what caused the planets to orbit and the stars to shift over time. The last F is finite because Aristotle's universe has an end. The spheres comprise everything. There is no outside, no void, and there aren't even infinite spheres. Lastly, the motion of the spheres comes from a Rube Goldberg-esque infinite energy machine, being kept from us by the deep state, Hillary Clinton, and George Soros so that the fossil fuel industry can keep a vice-like grip on our current way of life. Psych! Haha! Got you there. Again, dum-dum, you were really believing me. Hoo-hoo! Get owned again. Actually, Aristotle believed that the motion from the spheres got started from what he called a prime mover. The problem of motion for the spheres was important to Aristotle, because if they moved, where did the original motion come from? The motion couldn't come from nowhere. If you remember back to part 1 of the series, you'll remember that Aristotle was concerned with Parmenides and his question of change. Despite answering Parmenides about how change could occur with the concept of potential change, Aristotle still strongly believed that something couldn't come from nothing, and that included motion. With that in mind, what was the original mover of the spheres? If you said something in motion gave the spheres motion, then you could ask, well, what gave that last thing motion? On and on and on. An infinite regress would occur, and Aristotle was not okay with that either. Hence, an unmoved mover, or prime mover, was needed. Prime mover is also what I call it when my Paracelsian cape gets here from Amazon in one day. The prime mover is a far-out idea, even for us modern observers looking back with historical context. So I'm gonna quote Lindbergh on what the prime mover was. Lindbergh writes, "The prime mover is a living deity, representing the highest good, wholly actualized, totally absorbed in self-contemplation, non-spatial, separated from the spheres. It, or he, or she moves, and not at all like the traditional anthropomorphic Greek gods. The celestial spheres want to imitate the changeless perfection of the prime mover, so they move in perfect, changeless circles, hence where the motion comes from. Interestingly, each sphere also has its own prime mover which it is inspired by. Not super important, but something that you might not expect given what we have already gone over with Aristotle. Now, actually, lastly, Aristotle's universe was eternal and had existed forever. Again, it could never not exist because it's impossible from something to come into being out of nothing. This later caused problems for the church trying to Christianize Aristotle. And there you have it, fixed, full, finite. Aristotle's universe was centered around a single point, no empty space, filled with earth, water, fire, air, or quintessence. And the motions in the heavens came from a prime mover. Part 2. Motion. Part 2. We have already gone over some of Aristotle's beliefs about motion when we talked about the movement of the heavenly spheres, so this part will be a little bit shorter than the last. Now I want you to remember when I said to keep in mind the super and sublunary spheres. This is where the distinction is important. Aristotle believed that there were two types of motion, natural and violent. You can remember these two based off of how I act when I get hangry. Natural and violent. Watch out. Motion in the superlunary spheres was always natural and regular, hence the regular orbits. So I'm not going to talk about that anymore. The sublunary sphere is where all the action's at. It's where violent motion could occur. See, natural motion occurs when things move to their natural place in the universe. Generally, this is towards the center of the universe, at least for things like earth and water, heavier elements. Lighter elements like air or fire may be naturally inclined to move to higher elevation, as their natural place in the universe is above heavier elements like earth and water. That brings us to violent motion. Violent motion is motion that is in any other direction besides that which is natural. Violent motion occurs when an outside force coerces an object to move from its natural place. To be clear, things can move naturally, but only in straight lines to where they naturally belong, which generally just means things falling. Now, if an object loses the external force acting on it, it stops moving. Aristotle explained that things were able to have horizontal motion even when an outside force stops acting as a mover because the medium takes over as the mover. So, when we decide to throw a ball at the annoying neighbor kid who decides that 1 a.m. is a good time to scream about Fortnite, our action on the ball is also an action on the surrounding air, hence allowing it to propel the ball. Since Aristotle's world is full, some part of the medium is always impacting the next part, allowing the ball to travel until it gets to its natural resting place, hopefully hitting the neighbor boy and discouraging him from playing Fortnite so late. Force isn't the only thing that determines motion, though. There is also an opposing force, resistance. Aristotle believed that the quickness of motion depended on these two factors: the amount of force applied, and the resistance of the medium that it was moving through. Aristotle didn't write any quantitative laws explaining the relationship between force, resistance, and speed, but he did leave some salient examples in his work that I'm going to go over now. In On the Heavens and Physics, Aristotle claimed that when two bodies of differing weights descend, the time required to cover a given distance will be inversely proportional to their weights. In other words, an object twice as heavy will require half the time to fall the same distance as the lighter object. In other words, big things fall quick. The next example Aristotle gives in physics is that if two bodies of the same weight move through media of different densities, media is just the plural of medium. I didn't know that either until researching for this video. The time required to move through the given medium is proportional to the density of said medium. Aristotle's last example is that he says if a force moves against an object, away from its natural resting place for a given distance in a given time, the same force will move an object that is half the weight twice the distance in the same time. Or another way is that half the force will move half the weight the same distance in the same time. Part 3. Influence. What was the impact of Aristotle's theories of cosmology and motion on the rest of science? Aristotle's model of heavenly spheres was hugely influential. It's what Ptolemy based his map of the heavens on, which was used up to the 1500s and later when Copernicus published On the Revolution of the Heavenly Spheres and had a heliocentric model of the universe. In Latin, that's De Revolutionibus, which I think is also a great name for a Euro dance band. Aristotle's theories of motion were also widely used until around the same time period when Galileo came around, and until even later, around 1600, the majority of European universities taught Aristotelianism. Don't get me wrong, I'm not saying that nothing changed in science from the time of Aristotle to 1600. It did. There were huge developments in science during that time period. However, much of this innovation was built off of an Aristotelian framework, and his biology, which I'm going to talk about next week, was cutting edge up until the mid-19th century. That's why I call Aristotle the most influential scientist of all time. Think about that. Aristotle's science was the dominant science in the Western world for over 2,000 years. 2,000 years! I can't think of a single other scientist who comes close to that in terms of their impact or length of their relevancy. Speaking of which, if you have a counterexample or you disagree with me, please let me know down in the comments. As always, remember history is infinitely more messy, more complex, and most importantly, more interesting than I could ever cover in one video. If you enjoyed watching, please think about liking this video or subscribing. It helps me out and makes me happy to know that others enjoy what I work hard on. Thank you very much for watching and have an excellent day.